Welcome to the lecture series of Digital Electronics Digital Fundamental. In medium scale circuit, combinational circuit, let us design one problem. Design a BCD adder circuit using the 4-bit binary adder. As we know that in 4-bit binary adder, the input is allowed from 00000 to 1111. 16 combinations are there. Okay, this is for binary. While in BCD, our inputs are 00000 to 9. 9 is 1001. Okay. So total 10 combinations are there. Total 10 combinations are there. And 6 combinations are invalid number. So when we use the 4-bit binary adder, our inputs are BCD, so obviously the output is also generated BCD. Computer or calculator that performs the arithmetic operation directly in the decimal number system and which is in form of binary coded. So adder for such a computer must employ arithmetic circuit that accept coded only decimal number and present the result also accepted in decimal code. And in binary addition, it was sufficient to consider a pair of significant bits at a time together with a previous carry. A decimal adder requires minimum 9 inputs and 5 outputs. Since 4 bits are required to code each decimal digit, the circuit must have an input carry and output carry. Of course, there is a wide variety of possible decimal adder circuit depends upon the code used to represent the number. The design a 9 input and 5 output combination circuit classical method required 2 raised to n 512 different entries are there. Combinations. Many of the input combinations have a don't care condition since each binary code must have a 6 combination that are invalid. The simplified Boolean function for the circuit may be obtained by a computer generated tabular method and the result would like probably connection of the gate forming in irregular pattern and alternate producer to add the numbers with full adder circuit and taking into consider that the 6 combinations of in each 4-bit input are not used. The output must be modified so that it can be binary combinations which are valid combination decimal. Let's consider, suppose there is a 2 decimal digits are there in BCD. Okay. What is the maximum value possible? Maximum value in BCD. So single digit is 9. Second is 9, AZ and added. And carry in suppose maximum possible one. So 9 plus 9, 18 plus 1, 19. 19. 19 is the maximum value. The one in the sum being input carry. Suppose we applied 2 BCD digit number 4-bit in binary adder. Suppose I applied, there is a 4-bit binary adders are there. Okay. So first binary input, second binary input. The adder circuit output, how many outputs are possible? So outputs are 0 to 19 maximum. Okay. Minimum value is 0. If 0, 0 and carry in is 0, so result is 0. And maximum is 199. So 19. So my output is possible from 0 to 19. Okay. So let's make a one truth table for that things. Before that, let me erase everything is what we have done here. So this is the simple introduction that what are the values are possible in BCD. And as we discussed that the BCD values are possible 0 to maximum value is 19. So we have to make the truth table that we have a binary adder and in binary adder if the result is 0 to 19 how we can convert into BCD. Okay, suppose here I'm taking the input k for binary sum while in BCD the k is converted into the C. Okay, and Z is the binary output, binary adder output. I want BCD output to convert into the BCD. So better that thing, whatever the binary result is that convert into the BCD. So 0 is represented by 0 up to the 9. The result remains same because the representation of 9 in binary and BCD are same. But if there is a result is 10, so 10 in binary format 8, 4, 2, 1, 8 plus 2, 10. But in BCD it is represented by 1 and 4, 0. Remember that thing. It is the decimal. Here the main difference is that after 10, the difference is that the binary value of 10 is differ from the BCD value 10. BCD 10 is 0, 0, 0, 1 and 0. This is called as a 1, 0 in BCD. So 1 is the carry and last 4 bit is the sum output. Similarly for 11, 12, 1 and 2. This is the 2 and 1. 13, 14, 15, 16, 17, 18 and 19. Okay. So these are the actual output may be possible in examining content. It appears that the binary sum is equal to or less than 1001. At that time it is similar, both are same. The corresponding BCD number is identical and therefore no conversion is required. Here in this cell, there is no required additional circuit. Binary adder output is same like as a BCD output, but from 0 to 9 only. But if it is more than 9, when the binary sum is greater than 9, it is non-valid BCD representation. The output is not non-valid BCD number. These are non-valid BCD by number. A binary output. So the addition of binary 6, now compare this thing. Every number, if I add 6, it is equivalent to the binary. Okay. This is the 1011. That means 11. 11 is that 11 plus 6. If I add 0011, the result will become this. So 0, what I have to add? Plus 0110. This is equal to 6 in decimal. If we add this, the result will become equivalent to binary. So binary sum converts to convert into BCD represent produce an output carry is also required. At that time we need an output carry. So the logical circuit to detect the necessary correction can be derived from the table entry. It obvious that the correction is indeed when the binary sum has an output carry k equal to 1. Okay. When it is required, first up to 0 to 9 there is no required changes here, both are same. But if more than 9, so in this table first requirement is that k equal to 1 in this last 4 stage. If k equal to 1, the other 6 combinations, now how many combinations are remaining? 1, 2, 3, 4, 5, 6. So in other 6 combination, from 10102 to 1111. That means the correction 1 in the Z8. Now compare this thing here. Z8 equal to 1 in every combination. But here also Z8 equal to 1. So Z8 equal to 1 to distinguish that 1000 to 1001. This is difference. We have to differentiate from this all 6 number with these 2. So for that there is required Z8 equal to 1 with either Z4 equal to 1 or Z2 equal to 1. Okay. See here. Here both are 0. But in this combination, Z4 equal to 1. So here these 4 combinations say that Z8, Z4 equal to 1, 1. Here K equal to 1. And in this last 2 combination, Z8 and Z2 equal to 1, 1. Okay. This thing is not happen in this 9 combination. So we have a 3 logic. K equal to 1 and Z8, Z4 equal to 1, 1. Then Z8, Z2 equal to 1, 1. In these 3 combination, we have the whatever the input, output of binary adder circuit plus 6 generate the BCD output. Okay, so we obtained one equation C equal to K plus Z at Z4 plus Z at Z2. Okay, we derive this equation, this one. So when C is equal to, it is necessary to add 6 in binary sum to provide output carry to the next stage. So we put this equation and make a one circuit. This is my final binary adder circuit. First I add A plus B. Whatever the binary result, this is the binary output. Binary output we obtain output carry, this one C. C is equal to K, this one directly K. Then Z8, Z4 and Z8, Z2. This generate the C is equal to 1. When C is equal to 1, at that time, whatever the binary input plus 0, 1, 1, 0 will be add and generate the BCD output. What happens if C equal to 0? This is the condition 1. When C is equal to 1, the satisfied this and we obtain that there is as well as the BCD output. But if C is equal to 0, suppose, so C is equal to 0, at that time 0 already is there, but this will also 0, 0, 0. And in this circuit, x plus 0 is equal to x. Means if the output is between 0 to 9, at that time C is equal to 0, and at that time the final output is same like as this binary adder circuit. So BCD adder can be constructed with 3 IC package. Each of the 4-bit adders in MSI function and 3 gates. So 1, second and the third given, this one. Okay, 3 IC packages are required. So BCD adder is available in one MSI also. To achieve the shorter propagation delay, MSI BCD adder includes necessary circuit for look ahead carries, and the adder can be corrected. It does not require OR for 4-bit adder, but the circuit is optimized in IC, and this TTL IC, his number is 82S83. This is one IC is available, which is a BCD adder circuit. A decimal parallel adder that at n bit decimal needs n BCD adder. Okay, suppose someone is there that I want to design 4 digit BCD adder require 4 BCD circuit. Okay, 4 BCD circuits are required. The output carry from one state must be connected to the input carry to the next higher state. So in this way, we can design the BCD adder with the help of 2 4-bit binary adder. So I hope it is making sense everybody's how to design the BCD adder circuit with the help of 4-bit binary adder circuit. Have a good day.